Bismillahirrahmanirrahim. Assalamualaikum to all doctors and lecturers. So this is our proposal video from the group 4. My name is Muhammad Shazwan bin Abdul Hamid and I will go with the introduction and the problem statement. So we would like to say that the radiology department plays an important role in today's medical advancement. Doctors make use of the imaging equipment to acquire non-invasive access to human anatomy, make diagnosis and support treatment approaches. For the investing and cost of the department, the hospital are driven to invest intensively in their radiology department, such as to purchase the X-rays, the CT scanners, the MRI systems, the ultrasounds, and the fluoroscopy rooms in order to meet the imaging needs. For the design of the room, to meet the sensitive requirement of the imaging equipment, the imaging room should be specifically created at the proper place and ideal temperature. Among the imaging equipment, CT scanner will be given focus in this case. It's pricey but highly dependable. The uptime of the machine can be maximized by having ideal climate and environmental conditions that include investment in this device that can help to maintain the temperature and humidity, as well as staff training in the proper maintenance of the equipment. So for the clinical issue, the CT scans are very complex and consist of many delicate and expensive internal parts. These machines and their internal components are very sensitive to the ambient temperature and humidifier and the humidity. As abrupt change of the temperature can cause problems such as condensation inside the equipment. If the humidity is way over the limits, this may affect the electrical internal component of the equipment or any other crucial parts such as the X-ray tube, which can cause a lot of fakes. Thus, the temperature of the imaging rooms need to be kept between 18 degrees Celsius to 22 degrees Celsius throughout the days. Failure to maintain the temperature within this range will be cause the overheating of the machine, ultimately cause the damage to its inner parts. So the industry require a temperature monitoring system which can help the user remotely oversee the ambient temperature in the imaging room in real time to prevent any damage to the imaging equipment and their internal components in any unforeseen scenarios. So we will continue to the payee for the hypothesis and the experiment one. Thank you.
Good day, Doctor. My name is Kopei and I will now present about the hypothesis of our proposal. Firstly, we suggested to test for the parameters required in the designing of a temperature sensor, such as the relationship between temperature and forward voltage across diode, as well as how the temperature affects the conductance of a thermistor. Besides, we aim to understand and compare different types of temperature sensor available in the market, such as thermistor, thermocouple, and RTD. We also propose to have a self-assembled temperature sensor and test for its accuracy by comparing it with the system that is already in place in UMMC. Now, let us move on to the experiment outline. The first proposed experiment is about the diode temperature dependence. In this experiment, a simple temperature sensor is built by using a diode and a multimeter. Since the working of a temperature sensor depends upon the voltage across the diode temperature dependence is playing a crucial role in designing a temperature sensor. The amount of current flowing through a diode depends on the voltage applied to its terminal, which can be modeled using the Shockley diode equation as shown below. The reverse saturation current IS has a great temperature dependence. At constant voltage, a diode passes more current when the temperature is higher. For that instance, when we hold the current at constant, the applied forward bias voltage across the diode VD decreases as the temperature increases. The apparatus and materials involved in this experiment include diode, multimeter, alligator clips, thermocouple, masking tape, and temperature control hot plate. For the procedure of this experiment, firstly, the thermocouple probe and diode will be taped closely to each other on the hot plate. Next, the multimeter will be turned on and set it to diode test mode. The subsequent step is to attach the multimeter probes to each terminal of the diode using the alligator clips. Then, The thermocouple and hot plate will be turned on, followed by setting the hot plate to 30 degrees Celsius. The measurements of temperature and voltage will be taken from the thermocouple and multimeter respectively. The previous step will be repeated by increasing the temperature by 5 degrees Celsius each time until 60 degrees Celsius is reached. Lastly, the experiment will be repeated twice to obtain the average reading. Throughout the experiment, it is expected that the diode forward voltage decreases as the temperature increases at the constant current. Temperature is inversely proportional to the forward voltage across diode. That's all from me. Thank you.
Hello and good day to everyone. My name is Muhammad Hafizuddin bin Adnan. Moving on to our second proposed experiment, which is about thermocouple element. Thermocouple is one of the most common types of temperature sensor. Thermocouple thermometer works by the Seebeck effect that occurs when two dissimilar electrical conductors are connected together and a temperature difference is created at its junction. Under open circuit conditions where there is no internal current flow, the gradient of voltage is directly proportional to the gradient in temperature. The aim of the experiment is to apply the fundamentals and basic mechanism of thermocouple element, besides to calibrate and use a thermocouple thermometer in hope to better understand this type of temperature sensor for our project. The apparatus and materials used are pure nickel wire, nickel chromium wire, voltmeter, alligator clips, thermometer, wire cutter, and beaker. Two lengths of nickel chromium wire and one length of pure nickel wire are attached together to form two probes. The ends of the probes are connected to the voltmeter. The reference head is dipped in a beaker filled with ice water, while the measuring head is dipped in a beaker filled with boiling water. The voltage reading is recorded from the voltmeter. The procedures then are repeated but with measuring head tested in open air for the room temperature measurement. Then, the calibration constant, K, is calculated. Once the calibration constant is known, the procedures can be repeated with other temperature points. For the expected outcome, it is estimated that the voltage generated between the conductors at the measuring end increases when the temperature increases. In the end, the basic working principle of a thermocouple could be studied, including the percentage of error.
Greeting to all doctors and lecturers. My name is Dr. Azil bin Azan. AB1 is 0026. So I'll be explaining about the third experiment for our project, which is the effect of temperature on thermistor conductors. So for the experiment, our main equipment is the thermistor. So thermistor is a device that are strongly dependent on temperature. And there is two types of thermistor available in the market. First one is negative temperature coefficient and NTC, and positive temperature coefficient, the PTC. For our experiment, we'll be using the negative temperature coefficient. And these temperatures are governed by Boltzmann factor, which is due to the number of charge carriers available in the thermistor. So this thermistor work in the range of 50 up and 50 below of the range of the thermistor. For example, if the thermistor have a range of 0 degree to 100 degree, so it can extend to negative 50 to 150 degrees Celsius. And our purpose of the experiment is to study the effect of temperature on the thermistor and how it affect the resistance of the thermistor. The apparatus and material that we need to perform this experiment are crocodile clip holder, thermometer, thermistor, a negative temperature coefficient type, a beaker, a digital multimeter, and a hot plate. So the procedure for the experiment are, the first step is to clip the thermistor and put it into a beaker. Then we turn on the multimeter and set it to diode test mode so we can measure the resistance. Then the multimeter probes being connected to the thermistor by alligator clips. Then we pour boiling water into the beaker, and readings of the resistance through the thermistor have been recorded as the temperature of the water falls. So we take the result by the interval of 5 degrees Celsius, and then we plot a graph of resistance against the temperature from the results. Then the expected outcome of this experiment is as the temperature of thermistor decrease, so the resistance of the thermistor will increase. In this case, it happens because more charge carriers are released to engage in conduction in the process. That concludes the third experiment of this project. Explanation of the fourth experiment will be done by Fatim. Thank you.
Hello, my name is Nufata Atira, and I'll be presenting the experiment 4, which is the comparing the accuracy of different types of temperature sensor. The objective of this experiment is that we want to see the different types of temperature sensor and how they work, their characteristics. So first we have thermocouple, second we have thermistor, and the third one we have RTD sensor. For the apparatus and material, we have hot plate with stand, beaker of cool water, ice point unit, thermocouple connector box, RTD readout box, microvoltmeter, ohmmeter, glass thermometer, parameter thermometer, 2 thermocouple, RTD probe, and thermistor. So first we need to set up the probe before we start using it for the experiment. Set up the hot plate with the probe stand on the table. Place the beaker of water on the hot plate under the probe holder. Third, insert the glass thermometer until it is immersed to the proper depth. Be careful not to force the thermometer in its fitting. Loosen the fitting by hand and slide the thermometer up and down as needed, and then tighten the fitting finger tight. Next, insert the bimetal thermometer at least 2 inches into the water. Insert the RTD into the water and connect its cable to its readout. 6. Insert the thermistor into the water and connect it to the ohmmeter. 7. Insert one thermocouple into the water, connect it to one of the 2 TC connectors on the junction box. 8. Insert the second thermocouple into the electronic ice bath and connect it to the second TC connector on the junction box. 9. Connect the output of the junction box to the microvoltmeter. So this is the procedure for the experiment. Take an initial reading from each device. Compare the readings from the thermistor, RTD, and thermocouple to the theoretical values for the temperature indicated by the glass thermometer. Use the charts provided in the appendix to determine these values. 2. Start the water heating by turning the hot plate on to its maximum setting. Record data from each device at regular intervals from the current temperature to 90 degrees Celsius on the glass thermometer. Once it has reached 90 degrees Celsius, turn off the hot plate and allow the water to cool before touching any of the probes or the beaker. Once things have cooled, dump the hot water out. The expected outcome from this experiment is that we can gauge the accuracy of each temperature sensor and their respective range for measuring temperature. Thank you.
Hello again. Our fifth proposed experiment is about comparing the accuracy of our self-assembled temperature sensor with the system in UMMC. After assembling a basic temperature sensor, we intended to test the accuracy of the temperature sensor that we have decided to use compared to the temperature monitoring system that is already in place in UMMC. We would like to compare the ambient temperature of the imaging room when the imaging equipment is in use and when it is not used with the data obtained from the UMMC system's data logger. The results will be observed and analyzed to improve the future prototype design. For this experiment, we will assemble a temperature sensor by using an Arduino. The ambient temperature of the imaging room at different time points, for example when the imaging equipment is in use and when it is not, is measured by using the temperature sensor. The result obtained is compared with the temperature monitoring system that is already in place in the imaging room by the industry. By assembling our own design of temperature sensor, we can understand more about the basic principle of a temperature sensor. Besides, we can measure the accuracy and reliability of the assembled temperature sensor compared to the existing temperature monitoring system at the UMMC. The result is expected to be not perfectly accurate, but it will not be far off, as the existing system is not that complicated and totally precise either. So, that's all from our group for this project proposal. Thank you.